Okay, so let's dive in. You've probably used Apache Kafka dozens of times today and didn't even know it. In this explainer, we're going to pull back the curtain on the technology that's quietly powering some of the world's biggest real-time applications. So, let's just start with a basic question. Have you ever stopped to wonder how companies like Uber, Netflix, or your bank handle that constant, never-ending flood of live data? I mean, we're talking about a literal tsunami of information hitting their systems every single second. Well, the secret sauce, the thing that keeps it all from grinding to a halt, is a platform that works like a central nervous system for all that data. And its name is Apache Kafka. It sits right at the heart of everything, directing traffic with incredible speed and reliability. But to really get why Kafka is such a big deal, we need to understand the huge problem it was built to solve. And that problem is what we call the challenge of real-time data. This isn't just about storing stuff, it's about being able to act on it the very instant it happens. I mean, think about the constant stream of events coming from all our apps. Every single time your rideshare app updates the car's location, or you binge another episode of a show, or your bank flags a weird transaction, that's a real-time event. And there are billions of these happening every minute all over the world. So before a system like Kafka existed, trying to connect all those data sources to all the apps that needed them was, well, it was a complete and utter mess. Imagine trying to run a separate wire from every single power plant to every single light bulb in a city. It would be total chaos. This mess created what engineers call a spaghetti architecture. It was this tangled web where every system was directly connected to every other system. If one little piece broke, the whole thing could come crashing down. And trying to scale it up? Forget it. Adding any new feature was a nightmare because you had to weave it into this already tangled mess. And this is where Kafka comes in and just completely changes the game. The solution is so simple, it's brilliant. Instead of connecting everything to everything else, you just connect everything to Kafka. So what is it officially? It's a distributed event streaming platform. It actually got its start at LinkedIn and was open source way back in 2011. And it's designed to do three things exceptionally well. Get data from anywhere, store it reliably, and then let any application grab that data and use it. The easiest way to wrap your head around it is with an analogy. Just think of Kafka as a super organized, hyper-efficient post office, but for data. Packages of information come in, they get sorted, they're stored safely, and then they're delivered to whoever needs them exactly when they need them. All right, so let's take a peek inside this data post office, shall we? We're going to break down the core parts, because once you get these three components, you'll really understand where Kafka's power comes from. First up, you've got your producers. Simple enough, right? These are just any applications that are creating data and sending it into Kafka. In our post office world, these are the people dropping off the packages. It could be a website tracking clicks or a smart thermostat sending temperature readings. Now, that data doesn't just get dumped into one giant bin. Instead, it gets neatly organized into topics. You can think of these like specific mailrooms for different types of mail. You might have one topic for all the user clicks and a completely separate one for payment transactions. It keeps everything organized. And of course, on the other end, you need someone to pick up the mail. That's where consumers come in. These are the applications that subscribe to a specific topic to get the data they need. So a fraud detection system would be a consumer of that payment_transactions topic. So the flow is incredibly straightforward. A producer sends a message, Kafka stores it, and a consumer reads it. But here's the real magic. The producer has no idea who the consumer is, and the consumer doesn't care who sent the data. They are totally separate or decoupled. And that one simple idea is an absolute game changer. It lets different teams work on their own apps without breaking everything else. Okay, this all sounds great, but you might be wondering, how does this simple post office not get totally overwhelmed by that data tsunami we talked about? I mean, what happens when millions of packages show up all at once? Well, the secret is a clever trick called partitions. Kafka can take any topic and split it into multiple parallel streams. Back to our analogy, this is like adding a whole bunch of extra loading docks to the post office. Now, many trucks can load and unload mail all at the same time. And to handle all those loading docks, you can have a team of consumers, called a consumer group, working together. As you can see here, each consumer grabs a different partition and gets to work. So they're all processing data simultaneously. And if things get busy, you just add more partitions and more consumers to the group. It scales out beautifully. It's this amazing design, this mix of scalability and reliability that has made Kafka the absolute backbone for so many companies we use every single day. So let's talk about its real-world impact. And I'm not exaggerating. Get this, more than 80% of all Fortune 100 companies rely on Kafka. This isn't some niche experimental tech. It is the proven industrial strength foundation for the biggest businesses on the planet. It's used for just about everything. Real-time fraud detection, connecting all the little microservices that run a giant e-commerce site, powering live dashboards that show what a business is doing right this second. You name it. And the scale is just staggering. Companies like Netflix and Uber use it to process trillions, with a T, trillions of events every day. Every time you stream a movie, request a ride, play a song, yep, chances are Kafka is humming away in the background, making it all happen. So ultimately, what Kafka really lets us do is build systems that can react to things as they happen. It takes that chaotic flood of information and turns it into a structured, useful stream of data. It basically asks and then answers a really profound question for our digital world. What if every single event, every click, every purchase, every reading could be harnessed instantly?